Hey, going over the review for the second formative here. So this one's actually pretty short. It's all logarithmy. Right, so take a look here. I know in your paper it is hard to see. Identify the key features of this logarithmic graph shown below. So first thing we're going to do is we're going to look at the domain here. So for the domain, remember that's left to right on the x-axis. If I go towards the left, when does this graph start to exist? It doesn't exist at -5, doesn't exist here. It starts to exist at -3. So my domain here is -3 all the way to, and it keeps increasing. So it goes all the way towards the right, 3, infinity. So you can write your domain like this, or x is greater than -3. All right, let's change colors here. Range, for all logarithmic graphs, the range is always -infinity to infinity. Or you can say -infinity, y less than infinity, or everyone's favorite, all real numbers. Nope. All right, now I need to identify the asymptote. Remember, logarithmic graphs always have a vertical asymptote. So right here, the vertical asymptote is where the graph starts to exist, and it does start to exist at -3 for this graph right here. So if you look at it, like the graph is essentially sliding along this line, x equals -3. It's never touching it, but it's getting really close. X equals -3. Make sure you specify this as x. X is a vertical line, even though the x-axis is horizontal. This graph is definitely increasing. However, we do need to state the interval for when it is increasing, and it's increasing at the same interval as the domain. So I would just put -3, infinity, or x is greater than 3. So definitely get good with the key features of each graph. All right. So enough of the graphs. Now here comes the difficult part, figuring out what goes in log expressions. So choose the appropriate number that will make each equation true. So we need to think all here. So 4. 4 to what exponent makes 1/16? So logarithms can be confusing, so always change them if you can to an exponential expression. 4 to what exponent is 1/16? Well, it's 1 over, so I know there's a negative exponent. Well, how do I get from 4 to 16? That's 4 squared, so it should be a -2. All right. All right. What about the second one here? ln. ln, that's your natural logarithm. Remember, ln is the same as log base e. So this is actually saying log base e of e. So this is really saying e to what exponent is equal to e. E to what exponent equals e. Well, that's 1, right? 1 doesn't change anything. So again, if there's ln, ln is log base e. ln changes to log base e. This e is already there, so that just comes down. So there's a lot of e's here. Try not to get confused. This one's log. There is no base that they specified, so that means it's log base 10. So that means log base 10 of something equals 2. Log base 10 of something. So 10 to the 2 equals something. 10 to the 2 equals something. Well, what's 10 squared? That is 100. Yep, so 10 to what power? 10 to the 2 is 100. Let's think here. This is log base something of 49 equals 2. I have to read this as something to the power of 2 equals 49. What exponent, not exponent, what do I have to square to get 49? Oh, 7. 7 squared is 49. Rewrite all your log statements as exponential statements. Going to the one down here. Log base 4 of something equals 3. The equivalent exponential form is 5 to the power of 3 equals what? 5 cubed. 5 times 5 times 5, that is 125. Right? Log base something of 17 equals 1. So rewrite this as an exponential expression again. Something to the power of 1 equals 17. So what to the power of 1 is 17? Well, the power exponent of 1 means nothing changes, so log base 17 of 17 equals 1. This one right here. 6 to the power of negative 1 equals what? 6 to the power of negative 1 equals what? So negative exponent, don't freak out. That just means it's a fraction of 1 over something. Now let's ignore the negative. What's 6 to the 1? That is just 6. All right, last one here. Ooh, okay, this one does not have a base. If there's no base, then you have to pretend that it is log base 10. So this question is asking 10 to the power of 1 equals what? 10 to the power of 1 equals what? 10, because an exponent of 1 does nothing. Generally with logs, it can be really confusing. So there is a nice kind of trick that people do. Oh, it's a thing that they draw. So what they do is they start at the log base, and they kind of loop around to the number inside the log. So you would read this as, and this is how you would change logs from logarithmic form to exponential form. 4 to the power of negative 2 equals 1 over 16. All right, let's try for the one underneath here. 5 to the power of 3 equals 125. Another one. 6 to the power of negative 1 equals 1 over 6. So some people will draw this a lot just to kind of help them remember where to start when it comes from exponentials, because logs, it's a real backwards way of looking at exponential expressions. Okay. And finally, last here, for each statement below, write the symbol less than or greater than in the box. So I may mess up here. Apologize for that. So don't worry about this number. Keep this separate from this number. So if I have log base 3 of 50, what does that mean? That means 3 to some number equals 50. Whatever the numbers in the box is the answer for that. So what exponent makes 50? Well, 3 squared is 9. 3 squared is 9. No, it's definitely bigger than 2. 3 cubed is 27. 3 to the 4th is 81. Well, I know it's between 3 and 4. It's supposed to be 3 point something, right? That means the answer here, it's supposed to be 3 point something something. I don't know what it is. Well, 3 point something is definitely less than 4. So with these problems, you need to actually change them to an exponential form. Remember, the answer for a log is an exponent. So I know that it's log base 3 of 50 is supposed to be 3 point something. So that's less than 4. What else? Let's take a look at the second one here. If log base 2 of x is greater than 5, then x is blank of 32. So, well, what would I need to put in here in the x to even make it equal to 5? Well, remember, think of this as an exponential expression. So 2 to the power of 5 equals 32. That means if x was 32, it would be equal to 5. But I don't want it to be equal to 5. I want it to be greater than 5. I want an exponent bigger than 5. So if I knew that x was something that was bigger than, if this expression was bigger than 5, then I knew the exponent gives you something more than 32. So that should be greater than 32. All right, let's go to C here. Log base 4 of 50. So, again here, you need to think, what exponent on 4 makes 50? Well, 4 squared is 16. 4 cubed is 64. I know that whatever this whole thing is supposed to be between 2 and 3. It's 2 point something. Well, if it's 2 point something, it's definitely greater than 2. Greater than. Now, you can use a calculator and use the log base button to get this and then get an answer. That's a pretty short way to get the answer. This is more of a conceptual way here. All right, and the last problem here. Log base 3 of x is less than 4, then x has to be blank 81. So, well, before I think about less than or greater than, let's see, what would the x value need to make it, what would the x value need to be equal to the 4? So that would mean 3 to the power of 4 is what? 3 to the power of 4 is 81. Now, so I mean, if this 81 was in here, then it would actually be equal to 4. I don't want it to be equal to 4. I want it to be less than 4. So this number, it can't be 81. It's got to be smaller than 81. So, like, for example, let's say I put 27. If there was a 27 here, well, what gives me 27? 3. So I could use 3 as an answer. Well, yes, so right, 3 is less than 4, so 27 would be an acceptable answer there. So you need something that's smaller than what you would normally get. Right? And that's it.